Okay, wow. That was, apparently OBS started thinking my caps lock was control, which is great. Off to a great start. So, let's try this again. Hello everyone and welcome to Learn Solus Packaging Session 3-1, which is an advanced session that builds upon the work that we did for Session 3. So in this one, we are going to be covering actionable macros, Haskell, Meson, Python, and Qt macros. We will not be covering Perl and variable macros. And the reason for that is, at least for variable macros, we'll typically be using variables, so the variable macros won't matter particularly. We also won't be covering emul32 or applying patches. These will actually be covered in session 3-2, which I will be having 1 week from now. So let's go ahead and get started with some of the common actionable macros that you'll be dealing with. So first off, there are a lot of macros that we provide that are used by the GNU build system, or GNU make sometimes in our case, in the case of make and make install. So we have autogen and we have configure. Both of these are necessary. Well, we have autogen and reconfigure, and both of these are necessary if you're dealing with a source that does not provide a configure script, but rather a configure.ac file, or you have made modifications to the configure.ac file and thusly you need to reconfigure. But we also have the configure actionable macro, which actually uses which actually runs the configure script with the conf-ops variable macro. So we actually have an example of that, and our example is zsync. Zsync is a file transfer program. The gist of it is, if you have a copy of something on your local system, then it'll download only the changes to an upstream source from the remote server, which is kind of nice, so you don't actually have to download the entire thing, the entire file. So let's go over to the download page. Let's go ahead and right-click on this. And let's copy the link address and fire up a terminal. So I'm going to be using a fetch YAML alias. If you aren't familiar with it, then go ahead and check the packaging practices doc. That actually talks about what the script really is and how to set the alias. It's just one simple alias that makes it a bit easier to reference the script that generates the YAML file. So we are going to go ahead and do fetch YAML and then the source. And then we are going to immediately do echo the makefile.common to makefile, so it'll reference the makefile.common in the top directory as our makefile. And we are going to go ahead and fire up an editor. So we're not going to be worrying about the licenses and the components or summary or that sort of stuff. We're mainly going to be focusing on the actionable macros. So in this case, zsync doesn't actually need anything as a build dep. So all we have to do is have the setup, build, and install. So let's go ahead and remove the build deps because there aren't any, and therefore it's not necessary to actually have that key. Let's go ahead and save that. And then we are going to run make. Now if we do an ls, you can see it generated the zsync file. And if we do ls EO package zsync, it'll actually list the contents of the EO package. And as you can see, we have user bin zsync, user bin zsync make, and documentation and man files. Now let's go ahead and figure out how we are going to add additional files. Say we have a desktop file, or say we have a PNG that isn't shipped by the vendor, and we need to provide ourselves. Or in our case of zsync, it's just a completely empty file, and let's just go ahead and do it. So what we need is a files directory, which is relative to the package.yaml. So as you can see in our current working directory, we have that package.yaml. We're going to run make dir files. And next we are going to just do touch files/example, and that will create an empty example file. And as you can see in our files directory, we have that example. So we are going to use the install call with 00644, which is setting the UIDs and stuff. And we are going to install the package files example to our install directory in user share doc zsync. So that will actually install it, and if we were to rerun it right now, it would actually just put it in the zsync file. But what we are going to do is we are going to check out our patterns system, which is a way of explicitly listing how files are going to be split up into subpackages. So we're going to start off with this patterns list, and we are going to indicate docs. So anything that we are going to specify after this point in a list or array is going to be in that docs folder, docs subpackage. So we are going to specify everything in user share doc, and we are going to rerun make. And now if we do ls again, you see we have our zsync EO package and we have zsync-docs. So if we do an ls EO package on zsync, you see we have the zsync and zsync make and only the man files. And if we run ls EO package zsync docs, you see we have the user share doc content within there. Next thing we are going to do is we are going to touch on cmake actionable macros, and there's actually only one, which is our cmake actionable macro, which configures the cmake project for and with the distribution specific flags such as prefix and release type. And then after that we run make and make install. So in this example, we are going to be using peek, which is a really cool GIF screen recorder that's using GTK. So what we're going to do is we are going to go to releases, and we are going to grab this source tarball for the latest release, which is 1.0.1. So again, we're going to copy link address. We're going to do fetch YAML again, and we are going to generate the YAML. And as you can see, let's add the name there. It added our setup, build, and install, where the setup is cmake, and the build is make and then make install. So now we are going to go ahead and get the build dependencies because there are some. So we're going to go over to requirements and then runtime, and as you can see, it specifies that we need GTK, we need libkeybinder3, we need ffmpeg, and we need ImageMagick, as well as needing Vala. So we are going to go ahead and start listing out those package configs. So what I did was I did a EO package info on libgtk-3. I already know the package config, but I just wanted to go ahead and list these out again. As you can see, we're just going to pick the first one, which is package config gtk plus tac 3.0. So let's go ahead and do that. Next, we are going to need libkeybinder. So if you do an EO package search, you can see we have keybinder and then keybinder-devel. So we'll go ahead and do an EO package info on keybinder-devel. And as you can see, under the provide section of provide C package config keybinder -3.0 or package config keybinder, I'm just going to pick the first one. We're going to need ImageMagick. If I recall correctly, and I guess we'll find out, I don't believe we actually need the devel bits from ImageMagick. We're also going to need ffmpeg. So as you can see, if we do just EO package search ffmpeg, we have the -devel there. And once again, EO package info, and then we're just going to choose the first one. And we're also going to need vala. And it looks like we have everything. So let's go ahead and run make. And it's done. So as you can see here, we have peak and we have the contents, which includes that binary right there. So next we are going to be doing Haskell bits. Now before we actually jump into doing a package, I want to clarify that if you are building a Haskell package, then that is something that should always go into programming.haskell. And all Haskell packages need to have the Haskell Cabal install package as a build dependency. So we are actually going to be using setenv as our example, which is really simple because we don't need anything else besides that. But what we will need is the Cabal actionable macros, namely configure, build, install, and register. And register actually happens after install, and it generates a package config for the package and version, and then installs that config file. So configure runs the Cabal configure with prefix, libdir, and so on, and then Cabal build just does a build with our jobs count, and then Cabal install runs the copy for into the installer. So naturally, if you're doing Haskell stuff, you're going to go over to hackish.haskell.org, and you're going to use their search functionality and just type setenv. And then down here, you can see we have the setenv package. So we're going to copy that. And we are going to cd into our Haskell setenv folder. Obviously, that's not going to exist on your local system, so you will need to create it, but I did some preparation work beforehand. And we are going to generate the YAML for that. We are going to change the name from setenv to haskell-setenv. And we are going to need to specify that Haskell Cabal install. And we are going to want to do the install. Not the install, the register. I'm going to create the make file. And we are going to run make. And as you can see, we have a Haskell setenv EO package, and we also have the -devel one. And the Haskell setenv EO package has the shared object, it has some of their system files, their conf, and the license. And in the devel, it's going to have the static library. So next we have the Meson build system. And naturally, we have actionable macros for meson. So we have configure, which runs meson with our cmake flags and the appropriate flags like libdir. Meson build runs ninja with our jobs variable, and the meson install just runs meson install with the destination directory specified and the jobs variable. So in this case, we are going to be using cyber budgie screenshot applet because that uses meson. So we are going to go over to the releases page, and we are going to right click on the source tarball. You know how to do this at this point. And we are going to generate that YAML. And next we are going to go ahead and jump back over to and look at the dependencies that we need. So we need budgie-1.0, we need GNOME Desktop 3.0, we need GDK, we need JSON glib 1, we need libsoup-2.4, and we need Vala. Now these 5 are going to be package configs, and this one is going to obviously be just an explicitly listed package name as Vala. Now we don't actually need to specify GDK plus -3.0 because Budgie obviously depends on GDK at this moment in time. So what we are going to do is start listing out these now. He did us a favor just by explicitly listing the package config names, and these are actually going to be the same for us. So let's do some copy pasta. And instead of configure, we are actually going to use meson and meson configure and all that stuff. I'm just going to double check the libsoup package config. Okay, so it's going to be libsoup-2.4, which is what we have specified. Cool. We are going to do the makefile bit. Just double check this. All looks good. I guess we'll find out by running make. Yes, we need to specify meson. That would be helpful. Let's just go ahead and do a soul build update while we're at it. So that way we don't have to pull down those 13 dependencies over and over again. Let's do make. We are actually at the compile step. Yay. JSON glib. Oh no. There we go. We did it. We did it, people. If we do an LSEO package on the Budgie screenshot applet, you can see we have the shared object, we have the .plugin file, we have a bunch of locales and G schemas and the like. So next we have the qmake actionable macros. Sorry, the Python ones. Let's not skip things in the alphabet, Josh. So for the Python actionable macros, it's worth clarifying that when you're dealing with Python packages, if they're libraries or things that a Python application would use, then those should go into programming.python. And for Python 2 actionable macros, you are going to need to specify Python-setup tools. That isn't the case for Python 3, however. So for our example, I'm going to jump over to PyPy here, and we are going to be using the example WC width. So we are going to scroll all the way down, and we are going to right-click and do the copy link address here. Something to watch out for is the fact that it adds the MD5 hash, and you are going to need to remove that. So. And we are going to change the name from WC width to Python-WC width. And we are going to add the programming.python component. And in this case, we are going to use Python 3 setup and Python 3 install instead of the typical Python and Python, Python setup and Python install. And as you can see here under our actionable macros, we have those 4 specified. So basically the Python setup one will run the build portion, and then the install will run the install portion of the setup.py, and obviously the same for Python 3 setup, but with Python 3 instead of Python 2. And we are going to specify the Python 3-5 package config. And let's go ahead and do the usual compiling. And it's done. If we do the typical LSEO package, you can see we have the WC with egg files and tests and the like in the site packages for user lib Python 3-5. Now onto qmake. So qmake is used for Qt projects typically, and we have 2 actionable macros for those. We have qmake and we have qmake 4. Now qmake itself will run with Qt 5, and qmake 4 will run it with Qt 4. And the reason for that is for Qt 4 we actually have different executable names. So we have MOC, RCC, and UIC for Qt 4, and I'll actually pass those to our qmake. So in our example, we are going to be using tiled, which is a general purpose tile map editor. And we are going to go over to the releases. And we are going to do the copy source code. We're just going to update the tiled, update the name and the version first. And they actually have documentation on what dependencies you need. So it specifies that you're going to need Qt5 tools, and you're going to need this Qt5 default in Debian. For us, that's Qt5-base-devel, which isn't actually needed to be specified because Qt5 tools requires that. It's also specifying zlib, but because that is in system.devel, we don't need to specify that either. So really, we just need to look up the Qt tools bit. So if we do a search for EOPack for Qt5-tools, you can see we have the demos, debug info, and the devel, which is actually what we care about. And we are going to choose, say, Qt5 UI tools. It's also worth noting that we are going to need to specify GL as well from mesolib. Because it is a Qt5 application. And then instead of the configure, we are going to run qmake. And because they default to user local, which they specify in their installing section, we are actually going to need to pass prefix equals /user so it installs to the correct thing there. To the correct directory, and then in our make install we are going to need to specify the install root as our install dir. And we are going to run make. And as you can see, we now have the tiled and tiled-devel EO packages. And within that, we have the binaries, we have their libraries and plugins, their desktop files, and their icons that they provide as well. And in their tiled-devel, we just have that libtiled.so file. And that really is it in terms of the actionable macro. Obviously, if you love Perl, there are those as well. Tune in next time where we go over emul32, or I should say enabling 32-bit support for certain libraries is really handy if you are making improvements to the Steam runtime that we have, or if you're doing some sort of wine enablement. We'll also be doing additional files in terms of applying patches, and this could be useful if you need to make a change to a package, or to the source of it, I should say, or if you need to apply, say, CVE, so vulnerability patches, so the package isn't vulnerable to certain CVEs. So thank you for tuning in, and I will see you next time. Bye-bye.